This video shows you a sample Python notebook that analyzes precipitation data using pandas and matplotlib in a Watson Studio project. Start in the gallery and filter the contents to see just notebooks. Search for precipitation and open the sample notebook. Click Add to Project and specify the target project. Next, select a Spark Python runtime environment to use and create the notebook. Now wait while the runtime environment is instantiated. This sample notebook includes the output from the last run, so restart the kernel and clear the output. This notebook uses the annual precipitation data from the UNdata portal. You can download the data using these links in the notebook. Once you have downloaded the data, you can upload it into your notebook through the Files slide-out panel, which will allow you to access the data through this notebook programmatically. You can then use the Insert to Code link to insert a pandas data frame. This sets the configuration using your credentials and creates a data frame. The rest of the code in this notebook assumes a data frame with the name precipitation_df. So before running the cell, set the data frame name. The first thing you have to do is import the necessary packages, and then access the file in the object storage. And then you can load the data into a pandas data frame. Now you're ready to start data exploration. Here you can see the precipitation data for 5 different countries between 1990 and 2009. The next cell shows the precipitation data for the last 5 countries in the dataset. Here are all of the countries included in the dataset. The names of the countries are currently in a column. This next cell sets the names of the countries or areas as an index to the rows, which will be useful for plotting the data. You can start right away with plotting the data. First, you have to tell Jupyter to plot inline. And then you can plot, for example, Germany's annual precipitation data using the wrapper from pandas itself. Or we could import the necessary packages from matplotlib and use those directly for plotting the annual precipitation for France. If you want to know which countries or areas have the highest precipitation, you have to compute a sum for each country and add this additional column to the data frame. Then you can take the top 5 countries, China, Colombia, Venezuela, India, and Chile, from the results set and plot it together to compare the annual precipitation among these countries between 1990 and 2009. The same information can also be presented using a pie chart. You see here the top 5 countries and the rest of the world. Now you want to know which countries show a negative trend in annual precipitation. You could investigate each plot for each country, but you could also automate it and use a trend line approach to determine the trend by laying a line through the data distribution. Start by displaying a bar chart that shows the annual precipitation trend for Chile. The polyfit function fits a line through data points. By excluding the data points that are 0, the resulting slope indicates if the trend is positive or negative. If the line has a positive slope, that's a positive trend, and if the line has a negative slope, then that's a negative trend. For Chile, the line plot shows a positive trend in annual precipitation. The next cell uses the compute slope method to determine the precipitation trends for 91 countries. You can define the function for computing it and use the pandas apply function on each row for each country, and save this result into an additional column called trend. Then by simple selection, you can find out which countries have a negative trend in annual precipitation. Suppose you want to know which countries or areas display the steepest positive trend in precipitation. We'll leave this question for you to answer by reusing the previous code found in this notebook. After you have performed your analysis and get your results, you can share this notebook in different formats and send your work and results to colleagues. Find more videos in the Cloud Pak for Data as a Service documentation.